Okay, so in our week 4 of our assignment, we're given two more problems about the functions of random variables. Let's look at the first question. We're given the relation of two random variables like y equals gx, and the function is a piecewise linear function. It consists of four parts, like that. What we are gonna do is to find and draw the density function and the probability function of y. So the first in the beginning of our solution, I draw the function of y and x here. Well, it's actually not necessary to draw because the problem itself doesn't ask us to do so. But I think drawing it will help us illustrate my point that I'm going to express below. We could simply start with the density function f y. The first thing we're going to recall is that comes to my mind is the fundamental theorem, because we've just learned in our class. However, if we take a close look at our theorem, which is Fy equals Fx divided xf over g derivative of gx, that we're gonna realize that we could rely on some part, but it isn't everything. Since take a close look at this, the relation between y and x are sometimes horizontal lines when x are larger than 2 or smaller than 0 or between 0 and 1. There are three parts of horizontal lines, so the derivatives are zeros, and which are clearly cannot be the denominators. So we could only use the fundamental theorem when x is between 0 and 1. So we're going to try that this way. So we're going to try the first part when we're going to first discuss when x is between 0 and 1, and it goes like that. So when fx between 0 and 1. Between 1 and 2, sorry, 1 and 2, and derivatives is 1. So we're gonna substitute x with the function of y. So we can see this is actually a linear relation. So it's actually a one-to-one mapping, and there's nothing to worry about. So just simply substitute. Of course, we could also write it goes like this, and we could cross out the step function part actually, and instead we could substitute it with a for a certain interval y. It's actually between -1 to -1 to 0. So when y is between -1 to 0, the density function, we could write it via the fundamental theorem. It's like fx1 minus y. Okay. Let's look at all the other parts when y is constant. As we know, when y is constant means that when x covers an area, y it's stable. So the density function of y is actually like an impulse function with a certain area, and we're gonna know that we have to add three more impulse functions, and the origin of the impulse function is where y is located, y is located, and the area of the impulse function is the probability of x locating at the certain intervals, like this. When x is larger than 2, y is -1. So we know that the original point should be delta y, because y plus 1 equals 0, and the probability, the corresponding probability, which we are going to multiply by the impulse function, is the probability when of x larger than bigger than 2. So it's actually 1 minus fx2. Okay, we're gonna deal with the other two segments in the same way. So plus y minus 1, there's actually the 0.1, and the probability of x smaller than 0 is fx0, and that's for this one, delta y x is between 1 and 0. So if we wanted to do things a little easier, we could just add our step function back to our original question. We could write the density function in a one line way. So, but you could also write in segments. I think that's okay. So having get the density function of y, we could just do the integral to get the probability function. I'm gonna